The year 2024 has been a year of extraordinary heat, marked by a record-breaking El Niño event. This phenomenon has brought unprecedented temperatures, pushing the limits of what many regions can endure. Cities have sweltered under relentless heat waves, and rural areas have faced the harsh reality of drought, with cracked earth and parched landscapes becoming all too common. This warming of the Pacific Ocean has disrupted weather patterns worldwide, bringing intense heat waves, droughts, and floods. The impact has been felt across continents, with some areas experiencing severe flooding while others grapple with water shortages. The urban heat islands have exacerbated the situation, making life difficult for millions. But as El Niño fades, scientists are predicting a dramatic shift. The focus now turns to what comes next, as the climate system prepares for another significant change. Researchers are closely monitoring the data, looking for signs of the next phase in this ongoing cycle. La Niña, the cooler counterpart to El Niño, is poised to emerge in 2025, bringing with it its own set of dramatic weather changes. This shift is expected to alter weather patterns once again, with cooler sea surface temperatures influencing global climate in new ways. La Niña, like El Niño, is part of a natural climate pattern called the El Niño Southern Oscillation, or ENSO. This cycle is a fundamental aspect of Earth's climate system, driving significant changes in weather and climate across the globe. This pattern involves periodic fluctuations in sea surface temperatures and air pressure across the equatorial Pacific Ocean. These changes are not isolated, they interact with other climatic factors, creating a complex web of influences that shape our weather. While El Niño is characterized by warmer-than-average waters in the central and eastern Pacific, La Niña brings cooler-than-average waters to the same region. This cooling effect can lead to a variety of weather outcomes, from increased rainfall in some areas to drought in others. These seemingly small temperature differences can have far-reaching consequences for the global climate system. The ripple effects of these changes can be seen in altered storm patterns, shifts in monsoon seasons, and variations in agricultural productivity. The transition from El Niño to La Niña is a reminder of the interconnectedness of Earth's climate system. Each phase of ENSO plays a crucial role in maintaining the balance of our planet's climate, and understanding these patterns is key to predicting future weather events. Changes in one part of the system can ripple outwards, influencing weather patterns thousands of miles away. This interconnectedness means that a shift in the Pacific can affect weather in distant regions, highlighting the global nature of climate dynamics. As we move into 2025, understanding La Niña's potential impacts is crucial for preparing for the challenges and opportunities that lie ahead. Farmers, city planners, and policymakers must all consider these changes as they plan for the future. By staying informed and adaptable, we can better navigate the complexities of our changing climate and work towards a more resilient world. The El Niño of 2024 will be etched in our memories as a year of unprecedented heat and extreme weather events. This climatic phenomenon, characterized by the warming of the central and eastern tropical Pacific Ocean, brought about a series of weather extremes that left no corner of the globe untouched. From scorching heat waves that shattered temperature records across Europe and Asia, the relentless sun turned cities into furnaces. People sought refuge in the shade, and air conditioning units worked overtime. The elderly and vulnerable populations were particularly at risk, with heat-related illnesses spiking during the hottest months. To devastating droughts that parched farmlands in Africa and Australia, El Niño's impact was felt globally. Farmers watched helplessly as their crops withered under the relentless sun, and water sources dried up, leading to severe water shortages. The agricultural sector faced significant losses, affecting food security and livelihoods. The warming of the Pacific Ocean fueled intense rainfall in some regions, leading to catastrophic flooding in South America and parts of the United States. Rivers overflowed, streets turned into rivers, and communities were submerged. Rescue operations were in full swing as emergency services worked tirelessly to save lives and provide relief to those affected. The fingerprints of El Niño were visible in the heightened intensity of hurricanes in the Atlantic and typhoons in the Pacific. These storms, supercharged by the warmer ocean temperatures, wreaked havoc on coastal areas. Homes were destroyed, infrastructure was damaged, and the recovery process was long and arduous. Warmer ocean temperatures provided extra energy for these storms, making them more powerful and destructive. The storm surges that accompanied these hurricanes and typhoons caused extensive coastal erosion and flooding, displacing thousands of people and causing billions of dollars in damage. The economic and human toll of these events has been significant, highlighting the vulnerability of our planet to climate variability. Entire communities were uprooted, and the rebuilding process was slow and challenging. The psychological impact on those who lost their homes and loved ones cannot be overstated. El Niño's extreme weather events serve as a stark reminder of the interconnectedness of Earth's systems and the potential consequences of climate change. The melting of icebergs, shifts in weather patterns, and the increasing frequency of extreme events underscore the urgent need for global action to mitigate climate change and adapt to its impacts. As we transition into a La Niña phase, it is crucial to learn from the lessons of 2024 and enhance our resilience to future climate challenges. Scientists and policymakers must work together to develop strategies that protect vulnerable communities, improve early warning systems, and promote sustainable practices. By doing so, we can better prepare for the uncertainties of our changing climate and safeguard our planet for future generations. To comprehend the dramatic shifts of El Niño and La Niña, we must first grasp the fundamental forces that drive Earth's climate. Our planet's journey around the sun, combined with its axial tilt, creates the seasons we experience. This axial tilt, at approximately 23.5 degrees, ensures that different hemispheres receive varying amounts of sunlight throughout the year. During summer in one hemisphere, that hemisphere is tilted towards the sun, receiving more direct sunlight and experiencing warmer temperatures. Conversely, the opposite hemisphere experiences winter, receiving less direct sunlight. This cosmic dance between Earth and the sun is the foundation of our planet's climate system. However, the story of Earth's climate is far more complex than just the seasons. The uneven heating of the Earth's surface by the sun, combined with the planet's rotation, creates a dynamic and ever-changing atmosphere. Section 4. The atmosphere's engine, heat, wind, and the Hadley cell. The atmosphere is in constant motion, driven by the uneven heating of the Earth's surface. Warm, moist air at the equator rises, creating a zone of low pressure. This rising air cools and condenses, releasing its moisture as rain, which is why tropical regions experience high levels of rainfall. As the air cools and dries, it moves towards the poles. At around 30 degrees north and south of the equator, this air descends, creating zones of high pressure. This descending air is dry, leading to the formation of deserts at these latitudes. This circulation pattern, known as the Hadley cell, is a fundamental component of Earth's atmospheric circulation. The Hadley cell is not the only circulation pattern in the atmosphere. There are also mid-latitude and polar cells that contribute to the global movement of air and heat. These complex circulation patterns, driven by the sun's energy and Earth's rotation, create the diverse weather patterns we experience across the globe. Section 5. The Coriolis effect. Earth's spin and the dance of the winds. As air moves from areas of high pressure to areas of low pressure, it doesn't travel in a straight line. Instead, it curves due to the Coriolis effect, a phenomenon caused by Earth's rotation. The Coriolis effect deflects moving objects to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection has a profound impact on wind patterns. The trade winds, for example, which blow consistently towards the equator, curve westward due to the Coriolis effect. These winds played a crucial role in early exploration and trade routes, connecting continents and shaping civilizations. The Coriolis effect's influence on atmospheric circulation highlights the interconnectedness of Earth's systems. From the planet's rotation to the movement of air and ocean currents, every element is intricately linked. Understanding these connections is crucial for comprehending the complexities of global climate patterns. Section 6. La Niña's calling card. A shift in the weather pattern. La Niña, a complex weather phenomenon, is characterized by cooler-than-average sea surface temperatures in the central and eastern Pacific Ocean. This cooling effect has far-reaching consequences on global weather patterns. La Niña, with its cooler-than-average waters in the central and eastern Pacific, disrupts the atmospheric circulation patterns that El Niño amplifies. This disruption is not just a minor tweak, it can lead to significant changes in weather systems around the world. This shift in ocean temperatures influences the position of the jet stream, a band of strong winds high in the atmosphere that steers weather systems. The jet stream acts like a highway for weather patterns, guiding storms and influencing temperatures. During La Niña, the jet stream over the Pacific Ocean shifts northward, altering weather patterns across the globe. This northward shift can lead to a domino effect, impacting weather far beyond the Pacific region. One of the most significant impacts of La Niña is on rainfall patterns. The changes in the jet stream and atmospheric circulation can lead to increased rainfall in some regions and drought in others. Regions that typically experience drier conditions during El Niño, such as the southwestern United States and parts of South America, may see an increase in rainfall during La Niña. This can lead to lush landscapes and even flooding in areas unaccustomed to such heavy precipitation. Conversely, regions that often experience wetter conditions during El Niño, such as Southeast Asia and Australia, may see a decrease in rainfall. This can result in drought conditions affecting agriculture and water supply. La Niña's influence extends beyond rainfall patterns. Its impact is felt in various ways, affecting different regions in unique manners. It can also affect the frequency and intensity of hurricanes, the severity of winter storms, and the likelihood of heat waves and droughts in different parts of the world. For instance, the Atlantic hurricane season can become more active during La Niña years, while winter storms in North America may become more severe. Additionally, regions already prone to heat waves and droughts may find these conditions exacerbated, leading to significant challenges for communities and ecosystems alike.